Hello class! Hope everybody's having a fantastic day today. It's going to be a monumentous occasion in the lesson today. We're going to be talking about simple harmonic motion. Simple harmonic motion. Now this is going to be the first time that we try and apply trig to real life scenarios. And this all comes from what we call harmonic motion. Now, harmonic motion, it's a pretty basic concept. It's motion that is periodic in nature, such as the oscillation of a pendulum, something moving back and forth, back and forth. The orbit of a satellite, something that's going to go around in cycles. The vibration of a tuning fork, which again, if you strike a tuning fork, it's just back and forth really fast. Anything like that. If you were to, you could do this if you had a spring and you had a weight attached to a spring and you flick it. Same thing is going to happen here, right? So that's what we call simple harmonic motion. It's just something that oscillates between a high and a low. And that high and low can be a farthest left, a farthest right. It could be anything. It could be the tide coming into the beach. Right? At high tide, you have a higher amount of water, then it goes to low tide, and then it goes to high tide, and then it goes to low tide. On and on and on. Okay, well, this information here is going to allow us to apply trigonometry to basic life stuff. For example, number 1 here. It says the graph indicates the depth of water off a certain pier in Port Aransas, Texas, beginning at noon, March 19th, beginning at noon. Okay, so we have a little graph here. T is our hours, afternoon. So if it's afternoon, that means that 0 right here is going to be noon. Just a little information for you. 0 is going to be noon. So 12 hours later then, this guy right here would be midnight. Right? That's 12 hours later. And it says, y is the depth of water from sea level in meters. So y is the depth of the water. So let's think about that. What's the now if this is graphed, what this means here is that at noon it's here. At say 3:30 in the afternoon, it's at sea level. And then you get on to about 7 o'clock. You're at low tide. You come over here to about 14 hours after, which would be about 2 a.m., 2 in the morning, and you're at high tide again, right? So at noon, you're at high tide. Okay, what we're going to do here is see if we can pull out some information from this graph. So first, when I look at this graph, obviously it's sinusoidal, right? Simple harmonic motion. The last sentence up in the box here says that it's motion that can be modeled by a sinusoidal curve, either sine or cosine. Alright, so I've got a couple of things I can label here. I've got an amplitude, it looks like 3 meters, right? So I've got an amplitude of 3 meters. And then I can come up with my, my value for my period here pretty quick. It completes one full period in 14 hours, it looks like, going from here to here. So it looks like my value for P is going to be 14 hours. So really quickly, let's go ahead and come up with a value for B as well. B is going to be 2 pi over 14, which is just going to be pi over 7. That may come in handy a little bit later. B is going to be pi over 7. Alright, so just kind of keep that on tap there, and we may be coming back to that in a moment. So let's answer some questions. First one here, at what time and date is the first high tide? What time and date? Now notice they are asking for my date here as well, so that's important. Obviously after midnight, this is a new date, right? This is a different day. This is no longer March 19th, this is March 20th. So at what time and date is the first high tide? So my first high tide here at noon is going to be noon, and that is March 19th. March 19th. And then the second high tide happens 14 hours later. So that's going to be 2 a.m. and that's March 20th. Okay, the first low tide happens right about here. Okay, right about here. Not bad. So my first low tide happens 7 hours after noon, so it'd be 7 p.m. March 19. How long does it take to complete one cycle? Well, like we set up here, it takes 14 hours to complete a cycle. And then we get to our actual questions, our mathy type questions. It says write the equation in terms of sine. If you look at D, it says write the equation in terms of cosine. Because sine and cosine are both sinusoidal, meaning they make that sine kind of wave, we can use either one of them to model this thing. But here's the tricky part. In order for us to use sine, we have to start on the axis, right? We've got to start on the axis. Well, the first time this hits an axis is right here, right? This point. So this guy is going to be where the sine wave starts. Cosine has to start at a maximum or minimum. So cosine could start up here or down here. So we're talking about shifting it left and right, either left or right. So let's use sine first. Okay, this is my point. It's halfway between 0 and 7. Halfway between 0 and 7, this is 3.5, right? 3.5. So how do I move my sine wave? Let's write some equations real quick here. It says write the equation in terms of sine. So obviously this is going to be a function of time, right? So we'll call this f of t, function of time. And we're using sine. And what was my value for my amplitude first? Well, my amplitude from back up here was 3. So I can go ahead and put my 3 in front. But if you notice, if I start here with sine, I start by going down. So I'm going to need a negative sign in front of that 3. Then my value for b was pi over 7. I got that from back up here. My value for b is pi over 7. And then I'm shifting this graph right. So I'm going to do a shift right. I'm shifting this graph to the right by 3.5 hours. So that's going to be t, and since I'm going to the right, it's going to be t minus 3.5. Now, if you would like to go through with the calculator and graph those, if we have time, I'll show you at the end how to do that. Also, if you would like to write the 3.5 in terms of a fraction, that's perfectly okay. Either way is fine. Be 10 halves, I believe. No, that doesn't make any sense. 7 halves. Where did I get 10 from? Anyway, so write the equation in terms of sine. Here it is. I had to move it right, 3.5, your amplitude and your value of b. And then I have to come up with d, write it in terms of cosine. Write it in terms of cosine. Well, cosine, first off, it's a function of time, so f of t. I have cosine here. Now, if my cosine, let's start it back here just because it's easier to start at the origin. That way I'm not having to move right 7. Nah, that's no fun. Instead of that, say I start here. Have I moved it left and right? Nope. I've changed my amplitude, obviously. I've changed it to an amplitude of 3. Is it positive or negative? Well, since it's up, it's going to be positive. Right? Negative cosine would be down here. And then I've got cosine, and my value for b is pi over 7. And then t. Since I'm not moving it left or right, I'm done. All right? Now the question for E says, what is the depth of the tide at midnight, March 19? What is the depth of the tide at midnight, March 19? Well, good thing I know where midnight is. That's when T is 12, isn't it? So all I've got to do for that is take one of my equations here. Doesn't matter which one. They both should give me the same answer. Let's take cosine, just because it's a little bit more simple. Say we've got f of 12. So what I'm trying to find out is 3 times cosine pi over 7 times 12. Now I'm going to bust out my calculator for this. I'm going to make sure that I'm in the correct mode. I'm in radians mode, right? I'm going to make sure I'm in radians mode, and I am. So then I'm just going to plug it in. 3 cosine of pi over 7 times 12. 1.87. Now let's say we did it with sine, just for kicks and giggles. Negative 3 sine pi over 7 times 12 minus 3.5. And close my parentheses. Voila! Both the same, doesn't matter which one I use. Either way, I end up with 1.870 meters, and that is above sea level. Why is it important to say above sea level? Oh gosh, you can't even see that, can you? Why is it important to mention that it's above sea level? Well, that's because at midnight it is above sea level. If I came over here and did it here, it'd end up with negative. That means it'd be below sea level, right? Okay, and there's one more. It's on the back. I'm not sure why this printed on the back. I thought I had it spaced correctly, but that's my fault. The last one on the back is F. It says, find the first time that the depth of the tide is 1 meter. Well, the depth, that means that F of T is 1. Right? In other words, they want us to set our equation equal to 1. 3 cosine pi over 7 t. And they want us to solve for t. So we divide by 3. Please understand here that we are not dividing by cosine. You do not divide by cosine. You don't do it. Now what you can do to get rid of cosine is do the inverse cosine, and that's okay. So to cross this out, we're going to do cosine to the negative 1 of 1/3. We are not dividing out cosine. We're moving it over here with an inverse. So we end up with cosine to the negative 1 of 1/3 is equal to pi over 7 times t. Because remember that when you're taking the cosine, it's of all of this, right? So what's left over after cosine's gone? Well, this. Multiply by 7 over pi to get rid of this. 7 over pi. And what you're left with is t is 7 over pi, inverse cosine of 1/3. All right, 7 pi, ooh, wow, 7 divided by pi, much better, times the inverse cosine of 1/3. 2.7427, so 2.743. 2.743, and that is hours. 2.743. So that means over here on my graph, at 2.743, I have reached my height of 1. See that? At 2.743, I reached my first height of 1. And then we could go on and find all of the other heights of 1 if we wanted to, just by adding a simple period. Okay, so number 2. It says a weight is at rest, hanging from a spring, is then pulled down 6 centimeters and released. So you got your little weight here, right? You're going to stretch that sucker down this way and release it. The weight oscillates up and down, completing one cycle every 3 seconds. Very important for me. I'm going to underline that here. Completing one cycle every 3 seconds. Assume that no friction or air resistance is there, so it's going to keep going and going and going and going and going, right? Okay, so a couple things very important. It's completing one cycle every 3 seconds, and I pulled it down 6 centimeters. Okay? Graph the position of the weight at time t. Label each axis. So to start off here, I pulled it down 6 centimeters. Right? So we could call the vertical axis here, this will be position. This is position. This is measured in centimeters. And this is the position of the weight here. So this axis here is going to be time, obviously, because time is independent. All right. Now, it says that it completes one cycle every 3 seconds. That means that one period is going to pass 3 seconds later. Well, 3 seconds later, if you're starting down here, where would your one period be? It would be down here. Remember, one period later, you are at the same spot you were at the beginning. So halfway in between that, if you pull the spring down 6 centimeters and then you let go, halfway in between 0 and 3 seconds, if it goes up for 1.5 seconds and then down for 1.5 seconds, that's your 3 seconds, right? So in the meantime, it's going to go up here by 6, and it's going to hit right in the middle here. So it's a simple harmonic motion. So the spring is going to be pulled down. So the weight is sitting here doing this. It's coming down 6 centimeters, going up 6 centimeters, right? Coming down 6 centimeters, going up 6 centimeters. And all we're doing is graphing that over time. So a couple of things here. Your amplitude is 6. That comes from where it was pulled down. Your period is 3 seconds. That comes from every one cycle. So if we want to find B real quick, it's 2 pi over 3. So the equation to come up with this, is this going to be a sine or a cosine graph? It's obviously going to be cosine because it starts down here. So I'm going to start off with f of t, because it's a function of time again, and it's going to be equal to, it's a cosine graph. Your amplitude is 6, but since we started down here with a negative value, I'm going to throw a negative in front of that. Cosine of 2 pi over 3, and oops, not x. That's t. Okay? This takes a little bit of getting used to, but hopefully it's clicking along pretty good. So what is the position of the weight at 1.5 seconds? Well, if you remember, by pulling it down 6 and then letting it go, it's going to fly up, and it's going to pop above the axis till about 6, and it's going to fly back down. And that whole thing took 3 seconds. So 1.5 seconds, it'd be at 6 centimeters above the resting position. Ding. So it's going to be 6 centimeters above the resting position. Because resting would be here. And then we pulled it down and let it go. Well, you know, anytime you pull a spring down, it's going to fling it up just a little bit because it's a spring. That's what springs do. So we pull it down, it flings it up to 6. Come down, it flings it up to 6. Come down, it flings it up to 6. On and on and on. So for D then, it says use the graph to find the time when y equals 3.5 for the first time. Find the graph, or use the graph to find the time, so we're solving for t here, when y is equal to 3.5. So they want the first time when it's a positive 3.5. So it's going to be somewhere between 0 and 3, obviously, right? Alright, so we're going to set this thing up here as 3.5 is equal to negative 6 cosine of 2 pi over 3t, and solve. Now for the sake of time, I'm going to get this over here. You divide by negative 6, inverse cosine, multiply by 3 over 2 pi. Your t value is going to be 1.047 seconds. What does the 3.5 represent? What does the y value of 3.5 represent? Well, your y values here represent the position, right? So since it's a positive position, it's going to be 3.5 centimeters above the resting position. All right. One more here. I'm going to try and get this one done pretty quick. It's a good question. I love this question. Alternating current. This is something you use every single day of your life. When you plug your phone in to charge overnight, this is what's happening inside of your phone. Alternating current is a flow of electric charge that periodically reverses. See that periodically? It means it's going to be sinusoidal. Or it should be. Starts from 0, grows to a maximum, starts from 0. Kind of like the sine wave. Grows to a maximum, decreases to 0, and reverses, reaches a maximum in the opposite direction. Starts from 0, grows to a maximum, reverses, reaches 0, hits an opposite in the other, or maximum in the opposite direction, returns to 0. And it repeats the cycle indefinitely. The time taken to complete one cycle is called the period, and the number of cycles per second is the frequency. The number of cycles per second is the frequency. The standard in the United States is 110 volts. That's when you find a plug. Wish I had one here, but I don't. When you find a plug, well, they're all plugged in. Anyway, you know what a plug looks like. Plug you put in the wall. That's 110 volts. And it's 60 cycles per second. So your frequency, this guy, is the number of cycles per second. So it's 60 cycles in the US per second. So that means that if you complete 60 cycles in 1 second, that means that we can imply that one cycle, one period, one cycle would take about 1 over 60 seconds, right? It would take 1/60th of a second. If it completes 60 cycles every second, then divide it by 60, that's how long it takes to complete one. And the usual 110 volt household alternating current varies from negative 110 to positive 110. So this is actually important for us. If one cycle takes 1/60th of a second, then your period is going to be 1/60th, or 1 over 60. It's happening 1 every second, or 1 every 60th of a second. So very important here, write this down. Period is going to equal 1 divided by your frequency. Right? Period is the reciprocal of frequency. Okay, so graph the current at time t. Label each axis. So it just said up at the top, I got this from a problem. It says it starts from 0. So here's 0. It grows. It decreases. It hits a minimum, right? It grows, hits a maximum, decreases, hits 0 again, hits a minimum or maximum in the opposite direction, comes back to 0. And this entire thing takes 1/60th of a second. So this is time, and it's going to be in seconds. And this is current, right? This is how much current we're getting. This is in volts here. And it goes to 110. And then it goes down here to negative 110. So your amplitude, the amount of current you're getting, your amplitude is 110. Period is 1/60. So that's going to make your B value 2 pi over 1/60, which is multiplied by 60, 120 pi. And they want an equation to model this current. So we'll say f of t, because it's a function of time, is going to be 110, because that's my amplitude. It's a positive sign, so I'm going to use sine wave. And I know it's a sine because it starts at 0. Thank goodness for that. My value for B is 120 pi. And I'm not changing x right or left, up or down, so x. Okay? We got it just under the 30-minute mark. So a couple of things that you need to take away from this question specifically. Reading is extremely important. A lot of the stuff that I got down here came from this question. Mainly the fact that it started from 0. That tells me it's going to be sine. It's periodic, so that tells me it's going to be some kind of a trigonometric function. Grows to a maximum means it's a positive sign. Completes a cycle every 60 or completes in 1 second. It completes 60 cycles, which means it takes 1 cycle is every 1 out of 60 seconds. 1/60th. Good grief. 1/60th of a second. That's your period. And that let me come up with all of the rest of the stuff. All right? So it takes a little while to get used to. We're going to take the lesson real nice and slow when we get to class, but make sure that you go back if you need to, rewatch this. It'll be a good time. We'll talk to you later.